How do you navigate creating an app as an entrepreneur with little experience in tech? Here are 5 basic knowledge areas to light your path through the tech world. Hello and welcome. My name is Dale Richards, CEO of App Creative, an app development company on the Silicon Slopes of Utah. We're on a mission to build apps that change the world. If you want to build apps, grow your SaaS business, and make money doing cool software entrepreneur-related stuff, start now by subscribing and hitting the bell. As I set out to build apps for the first time, I already kind of had some background knowledge in software systems, kind of a basic knowledge. I had a lot of experience with project management, but I found that there were some areas where I didn't feel as strong, and I felt like it would be helpful to share some things so that every co-founder out there that does not have experience building technology can be more familiar with those items. So I've kind of hand-curated these 5 topics for you. So I'm going to cover these 5 areas, and hopefully you'll find this useful. Number 1, software architecture. What is software architecture? So this term refers to the structure of systems and how they relate to or work with each other. So try thinking about apps like cars, for example. In a car, you have several different parts like the engine, the fueling system, the electrical system, and each of those perform a specific function that helps the car run as a whole. Well, every app also has a few basic parts: a front end, a back end, and a database. In the software world, we don't call them parts. Instead, we call them components. These components can be organized into different layers of architecture. Front-end components are what the users are going to see, touch, and experience. So what you see on phones, for example, is the front-end code for the visual interface that you and others interact with. This does not apply strictly to apps. You can also have a web front end to be used on a web browser where they load from a server and run in your browser on your computer. Back-end components include all of the services that run on a server somewhere else, out of sight and out of mind from the users. For apps to do what they need to do and to function the way that you want them to, they rely on the logic and the code of the back-end layer. It's not something that you're able to see or touch, but it is code that runs on a server in a data center. There's also the database layer. The database layer is where the actual data from the app is stored. This may include personal data, payment card data, social media post history, transaction data. Any sort of data that is saved or put into the cloud actually lives in a database. The backend services read and write to and from the database. Now, these backend services can be of multiple types. We have what we call a monolithic backend or a microservices backend. Monolithic versus microservices architecture. So your backend is basically a bunch of code that runs on a server somewhere in a data center, like we said before. And at the risk of oversimplifying, your backend code can be built in one of 2 ways. You can have a monolithic architecture or a microservice architecture. Monolithic means that all of your backend code is one big code base. If you update one thing, you make a single change, you update the whole chunk of code. That usually means that you also have to retest all of that code every time you make a change. It can also be harder to migrate or move to a new server. It also means that if the server goes down, none of your app works. There are still reasons to have a monolithic backend. So for example, it's less expensive, so it can be a good choice for building a low-cost MVP or a proof of concept. So early on, if you're trying to build your first product, a monolith might be the right way to go. But we also have microservices. Microservice architecture means taking the same backend functions and breaking them down into smaller code bases. You can update the code for a single backend function without touching the code for all the others. This type of architecture is typically more complicated and expensive, but it isolates the services from each other. So if one of them goes down, the rest of them still work. They're still up and running. That could also mean that your users might see one part of your app stop working, but the rest of your app is still fine. There's also a concept called serverless architecture. In the monolithic and microservices scenarios, the server is always on, running in a data center, and you're paying for that server time in terms of hours of uptime. The problem is that if you load the server to capacity, you have to expand and pay for more servers. Like if you need more server capacity, you have to get more servers basically. And when your load decreases, then suddenly you're paying for a capacity that you're not using. So it's not exactly the most efficient way to spend your money. In serverless architecture, you're not paying for the server to run all the time. When the user's front end calls your back end, it spins up a server, runs the command, and then shuts it back down again. So you don't pay for a server to keep running by the hour. You just pay for the computing power to run that command. It's a way of keeping your variable costs more tightly aligned with your actual usage. Going back to the car analogy, if the back end is like an engine, then the front end would be more like the steering wheel or the dashboard or the gear shifter. They are working together to help the user accomplish a purpose, to get something done. When you open up a social media profile, for example, on your phone, you don't save it on your actual device. A small portion of it may be cached or stored temporarily, but all the different elements work together to serve up the content that you want to see. The front end requests the profile from the back end, and the back end retrieves it from the database and then serves it back up to the front end. Then you see it and interact with it on your phone. To get to this point where all the layers are working together, you'll need to go through a process called integration. During integration, the mechanics of the front end are then connected to the mechanics of the back end. Quick side note, the term integration can also refer to the connection between two different back-end systems, for example, like integrating your shopping cart with your payment processor, and that can also be a little bit confusing, but just know that integration is all about bringing two systems to work together as smoothly as possible. Infrastructure, also development versus operations. Now, as we look at the code, it needs to live somewhere so that it can run properly and perform its functions. The front-end code lives on your phone and uses your phone's resources, like memory and your storage. But what about the backend? Well, the backend runs on a server. In some cases, it may be a real, what we call a bare metal server. In other words, like a server computer that actually sits in a data center somewhere connected to the internet in a big stack or a rack. You can also have a server that's a virtual machine where an actual bare metal server is running something almost like a simulator to pretend like it's a separate virtual machine running on the bare metal. So the same thing goes for databases. They can run on real servers or virtual ones. In any case, they use up computing power, memory, and storage somewhere. The hardware used to run these elements of your architecture is called infrastructure. Once the code is developed, it is deployed to a server where it runs. The code is developed by a developer, and traditionally it's operated and monitored by whom we call a system administrator. Now note the distinction between development, the process of writing code, and operations, the process of running the code. While the code is operating on the server, it is called uptime, and that's good. The goal is to be as close to 100% uptime as possible. But when the system goes down, it's called downtime, and that's not good. It refers to a disruption of your service when a product has an outage. If you have an outage, your users can't access your back-end systems, and the front-end systems will only show them an error, which frustrates the users and causes you to potentially lose customers. Now, in recent years, we've had this concept called DevOps and also continuous delivery. And these concepts take development and operations and they've merged them together. And so what this means is that you no longer have a developer that writes code and then throws it over what we call the wall of confusion at a bewildered system administrator and just say, here, run this code. Instead, the developers themselves not only write the code, but also they add to it automated deployment and configuration scripts, including automated test cases. So the developers basically can check on their own whether the code will run on the server correctly. This empowers the team to deploy smaller, more frequent updates without waiting for a release. And this is possible because the deployments and tests are automated and go through multiple rounds of deployment, testing. Those rounds make up what we call a pipeline. And the practice of deploying code bundled with automated scripts and tests and ultimately releasing smaller updates to users more frequently is called continuous delivery, because you're always delivering new stuff to your end users. It is possible to build an MVP without using continuous delivery. We've done it more than once. But it also means that every time you release, you basically have to retest everything by hand, like all of it, the whole app. So you make changes to your app, you break something, you have to retest. Over time, it gets expensive, and to save you from the pain and headache, you might as well implement continuous delivery from the very beginning. Otherwise, you won't be able to release updates as easily, and your new features will be held hostage by manual processes. Databases. Let's look at SQL databases versus NoSQL databases. So, looking at databases, there are two main types. There are what we call relational databases, and there are non-relational databases. A relational database has tables with rows and columns. MySQL is a good example of a relational database. An SQL database requires that every row has a value for every column, and it looks something like this. So you have a record, right? That's the row in the table. You got like a record ID, a first name, a last name, a phone number. So for example, the record ID could be 001. The first name is Jane. The last name is Doe. You got a phone number there, 555-1234. And then basically you got a second row where you've got the next person, the next record in the database. You've got Adam Smith. He's record number 002. And his phone number is 246-801-3579. And so basically you got the same fields for both Jane and for Adam. So for every record in the database, all the fields are the same. Now, in contrast, non-relational or NoSQL databases are structured not as tables, but as documents. MongoDB is a good example of a NoSQL database. So a NoSQL database can offer more flexibility in describing stuff without requiring that every row has a value for every column. And it looks something more like this. So you got your document, you got your record ID there, you got your first name, Jane, and then the last name, Doe, and then the phone number, 801-555-1234. And then you've got her favorite dessert. Yeah, we're going to say that Jane's favorite dessert is strawberry cheesecake. So we've just added this attribute of Jane that says her favorite dessert is cheesecake, right? But then we've got another record in the same NoSQL database for Adam Smith. He does have a record ID. He's got a first name and a last name. He's got a phone number. That's all great. But then when we get to the other attributes, notice that we have an attribute for a favorite movie. So his favorite movie is Mission Impossible. His favorite city is London. That's different from what we said about Jane in terms of her favorite dessert. So we don't have to have the same fields for both Jane and for Adam. So you see how in the SQL example, all the fields are the same. Record ID, first name, last name, phone number. But in the NoSQL database, there's a line that describes Jane's favorite dessert and Adam's favorite movie and city. The different lines don't have to be the same from record to record, making it more flexible. It lets us store a wider variety of information without making the database huge. There are many moving pieces when it comes to developing an app, and it can be overwhelming and confusing when you start to learn about it. But as we start exploring the world of technology and app development, these things begin to change and become more clear, or at the very least, less mystic than they were before. So hopefully now you're ready to begin your journey into software development. So go out, build your app, change the world. We'll see you next time here on App Creative.